Okay, physics and projectiles. I want to walk you through one last problem that is a little bit trickier. So here we go. So again, I'm going to take something. I'm going to project it at an angle. And the thing we like to project, well, our favorite projectile. There it is. So it's going to go at an angle. There's a brick wall here, and the question is, where on the brick wall is it going to land? Right? So it's going to go along like this, someplace, maybe before or after the peak, I don't know, and it's going to strike it. So let's give it some two things. Let's say we have some distance to this wall, say 125 meters. Let's give it some initial velocity that's going. Let's give it a velocity, I don't know, 25 meters per second. Yeah, let's do slower, 15 meters per second. And let's give it an angle of, I don't know, 20 degrees. Let's lay out things we know. We're going to separate the x and y dimension. I know I'm going to have to separate my vectors, so let's just do that now. So I have velocity of 15 meters per second. I'm going to have to separate that into an x velocity and a y direction velocity. So velocity, my initial velocity in the y direction is going to be, well, here's my angle. So it's opposite. So this is going to be the hypotenuse times the sine of the angle, 15 sine 20. And there it is. And this one is adjacent, so it's going to be cosine. So velocity in the x direction is going to be 15 cosine 20. Okay, so let's figure this out. So I'm going to lay this out. So what do I know in my horizontal direction? What do I know in my vertical direction? And then we'll worry about a connector. A lot of times a connector is time. So let's figure out what we can. Okay, so horizontal direction. So my starting position is going to be 0. My ending position horizontally is going to be 125. What do I know about velocity? Well, my starting velocity in the x direction is 15 cosine 20. My ending velocity is going to be the same because acceleration is 0 in the horizontal direction. Really handy for us. And there's going to be some time. I don't know. I'll call that t. In my vertical direction, what's happening? So I'm going to call this y. Now, from a vertical direction, starting out is 0. The y final is what I really want to find. So this is going to be the height that he hits on the wall. That's what I'm after. So my initial velocity in the y direction is going to be 15 sine 20. My ending velocity in the y direction, I don't know it. I don't have to know. My acceleration is going to be negative g. So 9.8, I'm going to say downwards is negative, right? So I've already decided this is positive and upwards is positive. That's the plus sign. So my acceleration, and then I'm going to have time, which is going to be t, and this is going to be most likely my connector between these two. So it's going to be the same time horizontally and vertically to get there. So there it is. So the time is going to be my connector. Well, I'm looking at this. I can get to time. I think I can get to time using my horizontal information and then use that time then to figure out the height in my vertical dimension. So step one, I'm going to use in my horizontal. I'm going to say velocity is going to be displacement over time. Right? So I know the horizontal velocity and I know the displacement is going to go through. So I'm going to call this Vx. So again, I can calculate that, but I'm not going to do that yet. I'm going to save the calculations for the very end. My displacement, how far I've traveled, is 0 to d. So I'm going to call that d over time. So time, remember, I can switch these two. So time is going to be d over my initial, my horizontal velocity. So I'm good there. So now let's go into vertical. I come up with an equation for that works for vertical. So what do I care about in the vertical? So I care about the initial and final positions. So that narrows it down to a couple of equations. It could be, I don't care about final velocity. So since I don't care about final velocity, I'm going to use this one. Y naught plus V naught in the y direction times time plus 1/2 acceleration times time squared. Oh, it's going to be good. Okay, so what I'm trying to get to. So I'm trying to get to this y. This is going to be 0, so I'm going to drop that out. So let me replace h is what I want to get to. My initial velocity in the y direction Vy naught, I should say, times time. Well, time is this thing, so I'm going to say d over Vx plus 1/2 my acceleration, which is negative g, times d over Vx squared. Let me clean this up a little bit. So this is what I thought I was writing. So h is going to be v naught in the y direction times d over v of x, v in the x direction, plus 1/2. Well, actually, it's going to be 9 minus, right? So minus g d squared over 2 vx direction squared. I'm trying to see if there's like a simpler way to clean this up. You know, maybe, but I don't know. I think I'm just going to plug numbers into my calculator at this point. So let me plug in some numbers. So I'm going to have v naught in the y direction, which is going to be 15 sine of 20. I'm going to multiply this by my distance of 125. And in my velocity x direction, oh no, I got this backwards. So in the y direction, so oh, I had the right. So 15 sine 20, velocity in the x direction, 15 cosine 20. I could simplify that, but I'm not going to. So sine over cosine is tangent. So minus g. Remember, g is the value of 9.8. So we assign a positive and negative. We've already done that, so I don't want to do it twice. Times d squared, 125 squared. Divide this by 2 times velocity in the x direction, which is 15 cosine 20. Okay. Yeah, I pull out my calculator. Okay. Yep. So I stopped the video for a second because I got a negative value, but that's the way it goes. So when I plug this in my calculator, I get negative value 586. Right. So for a height, negative value is kind of a weird thing, but this is the answer that you get. And let me explain why it is. So the reason it's that way is because I made up a really tiny value for velocity when it is. So what does this mean, right? So let me put it this way. Right. I was asking where on this wall the armadillo hits when I shoot him off, right? So it turns out it's going to go like this, and when he hits the wall, he's going to be down minus 5,386 meters from where I threw him off. Right? So the math worked. I just set up a awkward problem. So anyway, the idea though, hopefully the idea came across where I'm going to separate my horizontal and vertical. I'm going to solve for one, and I'm going to trust that the math's going to work out, even if you get something really funky. Double check your calculations, and then see if you can make sense out of it. Hope it helps. Bye.